All right, so today in class, um, we started out with our epigenetic inheritance. So with the monster, so you'll draw your monster. So you guys know it had if you had a lot of stress, that would be a negative side effect. So maybe you had some kind of said something like cancer or something like that, or if you didn't have enough sleep, that one I know gave you like cancer. Air pollution gave you a chance of lung cancer, stuff like that, right? So you would draw that. You might have to draw some arrows labeling your monster, saying this is what's happening, blah blah blah. And then next to it, I want you guys to also draw a summary or write me a summary for every scenario that your monster had. So mom's pregnancy with her stress, mom's pregnancy with her diet. Then you go down to the monster itself, the monster's nutrition, the monster's exercise, X, Y, and Z, and say because of their exercise, they didn't exercise, so therefore they ended up obese. They lived out in the country, therefore the air pollution was low, meaning they did not have lung cancer, things like that. So that's what you write in your summary. All right, then we hopped on over to Polygenic Inheritance Height Lab. So what poly meaning many, so polygenic, many genes inherited. So why do some traits appear in nearly endless varieties? So polygenic traits are traits that are controlled by more than one gene. Like height, weight, hair, skin color, things like that. If these traits were controlled by Mendelian inheritance, humans would only have two heights, tall or short, meaning they have two different phenotypes. And we know that human beings, we have a large variety of these traits, right? Going from hair color, like we definitely have blonde hair, brown hair, black hair type of things. But obviously, we also have different shades of those blondes, different shades of those brown hairs, different shades of those black hair, things like that. So polygenic inheritance allows a wide range or a spectrum of traits. So today we're really going to look at today's lab, which is height. A man is 5 feet 7 inches tall. He has 3 heads. So we're using pennies. We use pennies a lot. Coin flipping, because it's totally random, right? Because how many sets of genes can a parent pass on to the offspring? And that's one, right? In human beings, we have 2 sets of genes, and you can only pass on one of those to your offspring. And then your offspring will end up having 2 genes, one from mom, one from dad. And so in this case, your dad has 6 genes for height. 2 sets of 3. He will pass on either one set tails or the other set heads. And so what's going on is he has 3 heads, and heads are for the tall gene. He has 3 tails, 3 are for the short genes. He will give 3 genes to his child. These 3 genes can be given randomly. He can give 3 tall genes and 0 short genes. He can give 2 tall and 1 short, or he can give 0 tall and 3 short genes. These are all some of the possible combinations that he can pass on to his offspring, right? So if we have 6 genes that he can pass on, but he can only pick 3 of those because he can only pass on 3 sets, they can go in a variety of combinations. The height of the mother will then dictate or decide the genes that she will give to the child. The combination of the mother's genes and the father's genes will decide the height of the child. Okay, so that might sound a little complicated at first, but it's really not too bad. So what you guys are going to do, so each group will flip all 6 coins at the same time. So again, we're doing 6 because 3 come from mom and 3 come from dad. And so I have 6 coins right here, or what you can do is grab 1 coin and flip it 6 different times. It's the same principle. So what you would do first for number 1, you're going to fill in table 1. Number 2 says record the number of heads and tails that result from each flip. So if I go to, I'll just go ahead and leave this up here. So if I flip all of these coins, all 6 of these, right? I flip them all, I go ahead and count them up. All right, so I go 1, 2, 3. Okay, I have 3 tails and on my first flip, and then I have 3 heads on my first flip. So I go ahead and write 3 and 3. I flip my second time. All right, so I flip all 3 of my pennies like I just did. I count them up. this is my second flip. All right, here I have 2 tails and I have 4 heads, and then I write that down. So that's what you do here. So you will do this randomly. So you're going to flip all 6 coins, or for each flip, you have to at least make sure there's 6 flips to it. Okay. Fill this table out. And then what you're going to do is you're going to drop down to your group. So in your group, how many times did you see 0 tails and 0 tails and 6 heads? Well, right here on my 7th trial, I had 0 heads and 6 tails. Are there any other combinations like that? Nope. So that happened once. Then I come over here. How many times did I flip 1 tail and 5 heads? So here's 1 tail, 5 heads. Have I done this anymore? Nope. My trial 4 was the only time I did that. So again, I would write 1. Okay. And then this was class total. You will have to get this when you come back. Actually, you can go ahead and take this one. This is a real one from last hour. So that's totally fine. So this is from 5th hour. This was our class total. So go ahead and finish your group total. Then the only thing that you had for homework for this is make sure you fill this out, this table 1, table 2, and now you're making a graph from table 2. And you're going to construct a bar graph for both your results and the class results. So you're going to make me a nice graph like this, and you're going to have your flip situation, 0 tails, 6 heads, are going to go down here. So you're going to have all of these different combinations of heads and tails. You're going to have them down here. Okay, so you're going to have 1, 2, 3, 4, 5, 6, 7. You're going to have 7 different one of these situations down here, just like they have written here. Then going up on your y-axis, you're going to have number of occurrences. So how many times did I see this combination occur? I saw that combination occur 1 time. So then you would draw a bar graph up to there and said, all right, this happened 1 time for my group, right? So there's graph 1, and that's going off of your group total, the one that you do on your own. Then once you're done with that one, you'll do your class total, which is this one in green here. So then you'll make a completely separate graph over here, and you'll do the same, and you'll label it the same way, right? We'll have our flip situation down here with all of our different coin combinations, and then we'll have our number of occurrences up here, over here, and make sure you space these out. Make sure you give it a chart title. I'm grading this graph, making sure that you correctly drew it. I'm going to do a grade on neatness, so make sure your lines are straight. Make sure that everything's evenly spaced, like these numbers right here for number of occurrences. Make sure these are all evenly spaced. If you want to use a loosely piece of paper or like a ruler to do that, that would be great. But other than that, it's just these 2 graphs and these 2 tables that are due for Friday. All right, we'll see you later. Bye.